Today's topic is called derivative basis other than e. Let's start with what type of function that has a base. There are two functions that contains a base. One being exponential function, second one being a logarithmic function. Previously, we learned how to take the derivative of a function that has a base of e. Exponential function will be e of x. Derivative of e of x will be e of x. Logarithmic function, it will be log base of e, which is also known as natural log, ln of x. And the derivative of ln of x, it comes out to be 1 over x. This time, we're going to learn how to take the derivative that has basis other than e. So that will be something like f of x equal to 5 of x, f of x is equal to 7 of x, 20 of x, and so on. I'm going to notate the constant with an a. Just keep in mind a is a constant, but it cannot equal to 1. And that's because if your base is 1, technically that's a number, not an exponential function. And that's because 1 to any power is equal to 1. So the derivative of a of u is equal to ln of a times a of u times the derivative of u. Again, u in this case is your exponent. Logarithmic function, we're going to notate that with log base of a of u. And the derivative is 1 over ln of a times u, that quantity, times the derivative of u. Let's look at our first example. Find the derivative of 3 to negative x squared minus 2. So in this case, our exponent becomes your u. So we're going to say u is equal to negative x squared minus 2. So therefore, our f of x could be written as 3 to the u power. So the derivative of that will be ln of 3 times 3 to the u power times the derivative of u. And our derivative of u is negative 2x. Now let's simplify this and also substitute back in your u to the exponent. So our answer will be the derivative is equal to negative 2x times ln of 3 times 3 to the negative x squared minus 2 will be our answer. Now let's look at our second example. This one is a logarithmic function. F of x is equal to log base of 3 of cosine of x. So once again, our u will be cosine of x. So our function is log base of 3 of u. And the derivative will be 1 over ln of 3 times u, this quantity, times the derivative of u. And our u was cosine, so the derivative will be negative sine of x. Once again, let's substitute our u back in and simplify to get our answer. F prime is equal to negative sine of x over ln of 3 times cosine of x. And we know sine over cosine is equal to tangent, so the answer will be negative tangent of x all over ln of 3 will be our answer. Example 3. Find the derivative of x times 2 to the negative x power. So now we have our exponential function times our algebraic function, which means you have to use a product rule. I'm going to call this g. I'm calling the second part h. So we have g is equal to x h is equal to 2 to negative x power. Derivative of g will be just 1 because derivative of x is 1. Derivative of h requires derivative of exponential function that is base other than e. So this will become ln of 2 times 2 to the negative x power times negative 1. So we could say our h prime is equal to negative ln of 2 times 2 to the negative x power. This is also equal to ln of 1 half times 2 to the negative x power. Now going back, in order to solve our f of x, since it was g times h, it requires a product rule. So the derivative of f will be g prime times h plus h prime times g. G prime was 1. H is 2 to the negative x power plus h prime was ln of 1 half times 2 to the negative x power times g. G in this case was x. Now we do have something in common, so I'm going to factor that out, and that will be our answer. So f prime of x is equal to 2 to negative x power times 1 plus x times ln of 1 half will be the derivative of x times 2 to the negative x power. Okay, to summarize our lesson, we were learning how to take the derivative of a function that is base other than e. Again, keep in mind our a in this case will be a constant other than 1. If you're given an exponential function such as a to the u power, your derivative will be ln of a times a to the u times the derivative of your u. For logarithmic function, your derivative will be 1 over ln of a times u, that whole quantity, times the derivative of u.